Conservation of energy. How do we apply conservation of energy to a situation? So in the previous lesson we talked about energy transformations. Now we're going to look at how we can make that useful for us. We will be drawing a bar chart showing energy amounts at different stages of a process. We should be able to describe in words the energy transformations that happen during a process. We should be able to write an equation stating conservation of energy and solving for an unknown, as is usual for us. Oscillate. That just means to undergo motion that repeats the same way over and over again. Could be back and forth. It could be bouncing up and down. Maybe you can look at it like this, where it's a circle and it's going the same way over and over. Oscillation involves kinetic energy becoming potential energy, which becomes kinetic energy again, which becomes potential energy again, and that will repeat forever. Amplitude is the distance between the center of an oscillation and an endpoint of the oscillation. The symbol for amplitude is A, and amplitude is a distance, so it's measured in meters. Dampened oscillation, an oscillation that does not repeat exactly the same way over and over again because some energy is dissipated during each cycle of motion, often by an external force. So kinetic energy will still become potential energy, which will then become kinetic energy, and back and forth, but energy is lost because there's something stealing that energy. Conservation of energy. Total energy before equals total energy after. Not a new concept here, so we can blow right through this probably, right? Conservation of energy means two things depending on whether the system is being considered closed or open. If the system is closed, it cannot exchange energy with other systems. So energy can't leave, energy can't come in. The total energy of the system, the sum of all the energies, before something happens is equal to the total energy after. If the system is open, then the system will exchange energy with other systems. So what that means is if I have energy and then I lose energy, that energy has to go somewhere. If I don't have energy and then I gain energy, that energy had to have come from somewhere. If a system is closed, then conservation of energy can be written with the basic equation. The first equation I want you to use, or to think about at least while you're doing this for the first time, which is exactly the first time, is your total mechanical energy in the beginning has to equal your total mechanical energy in the end. So this form serves as a reminder. Okay, so I need to add up, I need to get the total of my mechanical energies. What are those mechanical energies? Gravitational potential energy, spring potential energy, kinetic energy, thermal energy. Okay, so those energies, I need to add up all of them on the left side, and they need to equal all of those energies on the right side. Sometimes you don't need to use gravitational potential energy. Maybe it's just going to be your kinetic energy plus your spring potential energy. And that's going to be turned into, I don't know, thermal plus kinetic energy. Okay, so now we can figure out how much thermal energy there was. Or maybe it's kinetic plus gravitational potential equals gravitational potential plus kinetic plus your thermal. And you want to figure out how much energy did you lose to thermal energy. So whenever you have thermal energy, it leaves your system, right? Because remember, that hot plate, when it's hot, it's being dissipated throughout the room. So whenever you have thermal energy, it's going somewhere. It's being dissipated. Okay, so back to... Here's another basic equation. Kinetic energy plus gravitational potential energy in the beginning has to equal kinetic energy in the end plus your gravitational potential energy in the end plus your dissipated energy. This is not useful to memorize. That's why I like to use the TMEI equals TMEF, because there's situations where sometimes you're not using all of these, or you're using the spring potential energy, and it's just a little bit more universal. So a bonus happens when any of these are 0. That means you can cancel it out, makes your life a lot easier. So we're going to be looking at a bunch of different examples as we go on.